survey math is what we're going to go over next. In survey, you have different types of units. You have the English unit and you have the international, the metric, the SI system. Here in the States, we almost always use the English units, feet, yards, inches. We do, however, back in the 70s, FDOT or the Department of Transportation decided that they wanted to try to go with metric in plans, and a lot of the roadway plans are still in metric. But here's the deal: the contractors and the guys that you're buying your pipe from, guess what? Those pipes are still in inches. Even though the plan says millimeters, now the contractor has to convert to inches to buy the pipe and the material he needs. So most of the time you'll see everything still in the English units. Now here's the other thing that's super duper important is the basis of the survey foot. There's an international survey foot and there's a U.S. survey foot. If you look at the U.S. survey foot, notice the digits. 1 foot equals 0.3048006 meters. Well, the international standards people said we want to forget that last 6, so we're going to make it and we're going to round it. So 1 inch equals 2.54 centimeters, right? Makes it easy. Well, here's the thing is almost all of Florida is still in the U.S. survey foot. Now you don't think that 0.006 at the end, way down there, is going to matter that big of a difference. It doesn't at a short distance, but when you start telling a multiplication of 1,000, 10,000, 20,000 miles, that becomes a major error. That becomes a bust in the data where you thought something was is now not there. Okay? So almost always we use the U.S. international foot. Okay? Just remember that if you do get to work with the surveyors. The other things that you can pull up old plats, old 1800s earlier, you'll have old Spanish units called the var. The imperial system, you'll see a rod or a pole, and then you have chains. So 1 rod equals 1 pole equals 16.5 feet. 1 chain equals 44 rods. 1 chain is equal to 66 feet. When I say chain, I'm literally talking about a metal chain that has 100 links in it. Okay? Because back in the day when they measured all of Florida or all of the United States, they were measuring them not with these new fiberglass handy-dandy tape measures, they were measuring them with metal chains, and they were pulling them across the land. So they had to be something that was rugged. Okay? So 1 chain has 100 links. 1 mile equals 80 chains, and 1 mile equals 380 rods. Now this is old school. You'll see it in old plans, not new. We don't do anything like that anymore. But if you ever have to convert, then you'll know what we're talking about if you hear that terminology. Sometimes that chain is called the Gunther's chain. In the English, in the metric, you have 1 kilometer equals 1,000 meters, 1 meter equals 100 centimeters, and 1 centimeter equals 10 millimeters. It's very rare you see this unless you're talking about, and most surveyors don't. Most surveyors don't. It's the engineer that actually converts it into their engineering plans. And then you've got 1 foot equals 12 inches, 1 yard equals 3 feet, and 1 mile equals 5,280 feet. Now, one thing I should have put on there, because that's in linear, in area. We'll get to that in a minute. The other mathematical units is the angles. Here in the United States, if you're working with the engineer, you're going to have decimal degrees. It's going to be 30 degree or 30.5976435, whatever. And it's just going to be decimals. If you're working with the surveyor, he's going to say degrees, minutes, and seconds. Almost the only people that use degrees, minutes, and seconds are surveyors. Mechanical engineers, all of those are typically going to use decimal degrees. Okay. In military, you've got 640 mil per circle, or 6,400. I'm sorry. In Europe, you're using the grad. Now, here's the other thing: is the radian is actually unitless. It doesn't have a unit, but you can convert back and forth to radians and degrees. Okay. All right, quick. This is going to look similar to possibly your homework. Convert the following distances given meters to the U.S. survey foot. So I've got 4,129.547 meters, and in red is the answer. But over here I show you how to convert it. I even show you that 12 millimeters equals 39.37 feet. So I do the conversion here. It's called the box method. Anybody that needs help with some of these basic conversions, because it will be on the first test, come see me. But these are the typical units. You should have had tech math before this class, and that would have been covered there. But if you do need help, by all means, send me a message and we can go over it. Same thing here. You've got 5,370.52 feet, and I want to convert it back to meters. So I use the same conversion units. When you're doing conversions, you're going to be stacking them on top of each other. So you notice that I have feet here multiplied by something on meters, meters being on top, feet being on the model, so I can cancel out my feet and then just multiply across. All right. I'll be honest, when I took the professional engineer's exam, I was all about my units. If I didn't know how the equation worked, if I could set up my units accurately enough, I could get close to what I was looking for, because a lot of it was based on unit conversions. 10 chains, 13 links. So we said 13 links. There's 100 links in one chain. Links go on the bottom so I can cancel it out. And then I add my 10 chains. And then I say there in one chain is equal to 66 feet. So I cancel out my chains and I get the total of 668.6 feet. When you're multiplying area, I go ahead and multiply chain by chain. So the 917 multiplied by the 1064 gives me 97.56. I told you I use all my decimal places. I will go on till infinity if I could, but I'm tired at 4. And then I convert that squared chain, and we said 10 chains squared is equal to 1 acre, or 10 acres, and then just multiply it across. You do have a lot of conversions in the civil area, all right? Now, significant figures, there's these two rules that says significant figures. When somebody says significant figures, it's actually talking about how many decimal places do I hold, or how many figures are in there. It's not only decimal places. So the first rule says in multiplication or division, the answer has the same number of significant digits as the factor with the least significant digits. The second rule is in addition or subtraction, the decimal column is significant only if the digits of the terms are significant in that column. An insignificant digit in any decimal column makes that column insignificant in the answer. That sounds like a lot of yada. So let's take a look at before I start that, let me go ahead and explain rounding, and then we'll take a look at examples for significant figures, all right? In rounding, we know that the rules that if the digit next to if you're rounding, and let's say you want to round the 78.374 to 2 digits, since the digit next to the 7 is a 4, we don't make the 7 anything greater. The 4 stays as it is. We drop the 4 and it stays as it is. If we say, all right, we got 78.3749, and we still want to round it to 2, since the 4 is still next to the 7, I don't care what's after the 4, it's still rounded to the 7. All right. The second one is if there is a 5, when the digit to be dropped is exactly 5, the nearest even number is used for the preceding digit. For example, 78.375, so if it's a 5, that one rounds to an 8. So in this one, if it's an even number, so 7 is odd, so it rounds to an 8. If it's an even number, it stays the even number. Statistically speaking, I don't care whether you round the odd number up or round the even number up. Statistically speaking, if you keep the same pattern in what you do, it is going to average out. That means if you do it enough times, I don't care how you do it, but if you do it the same way every time, you will get an averaged out number, okay? Because I can never remember what I'm supposed to round up or round down. So I'm like, forget it. I'm going to pick one, and I'm going to stick with that one, okay?
Just one thing. On the second one is 78.385, right?
Oh, my bad.
Yeah.
Apparently I can't type. So it should have been a 2 here, not a 3. Thank you, Hannah.
No problem.
All right. This is what happens when it goes into a Prezi, and I can't change the Prezi once I've downloaded it. Oops. When the digit to be dropped is greater than 5. So if I have 78.38986, if the 8 is what I want to figure out the rounding, 6 is greater than 5, and I round up. I know this might be just common sense, but I want to just make, you've seen it before. I just want to make sure you understand it. Here's the example that I wanted to show you on significant figures. So if I line up all these digits, I've got 23.15, 0.984, 124, 12.5. I hold my decimal place. Notice there's nothing after that one. But this one has a boatload after it. As an engineer, I would want to use all of my digits. As a surveyor, they say this one is the one that's got the significant digits in it, so it's going to control. So you're not going to hold anything after that, but you will use the rounding. If I know I can only go to the decimal, to the left of the decimal place, then I round up to 161. Okay. If there was a digit after, if there was a decimal place and a 1, then you would hold to 1 decimal place. Now, the multiplication and division bother me. I'll tell you that right now as an engineer. It bothers me. Take a look at the two numbers. 276.75 multiplied by 33.7. So the least significant digits is going to be the 33.7, right? It's only got 3 digits in it. When I multiply those together, it's 9,326.475, and it goes on. But because there's only 3 digits, we're going to round this to only 3 digits here. So it's 9330, because the 9 rounds the 2 up to a 3, and we just forget the rest of the digits. We hold them as a 0. Okay, there to me is a bit of a difference between 9,330 and 9,326, right? So that bothers me as an engineer. But precision says I only have 3 significant figures. And based on significant digits, that's how this goes. Now, there is a website that I've posted online if you want to learn more about that. I'm going to let that go. I will not be testing you on significant digits, so no worries there. Okay. If you're working with an engineer, make sure you give him all the digits. If you're working with a surveyor, ask him how he wants it to look. We're going to pause here, and then we're going to go over safety next.